Hello friends, good morning to Engineering Wala channel. Today we discuss about the simple stresses and strains. So types of force is generally classified into point load and distributed load. Point load is a very small area which is considered as point. Point load is known as where the point is acted exactly center of the two fixed point. This is known as point central load. Now discuss about the load distributed load. A load distributed over an area or along a length is called distributed load. Here we discuss in this diagram in two fixed supports, and whole the load is acting on the beam. So according to the nature of action, it is classified into three types: static load, dynamic load, and fluctuation or cyclic load. Static load gradually increases from 0 to and remain constant during the entire time. In the static form, when the load is at rest and gradually increases. Example: a load hanging from the chain without raised or lowered. Example: when the hook is hanged by a very load, it will raised or lowered. Second one, we know that dynamic load refers to the impact or falling load. It is known as impact load. Example: pile hammer are dropped on the pile. When the hammer is dropping on the uh, another body, it will impacted. So third one is a cyclic load or fluctuation load. Cyclic load or fluctuation load refers to the load in which the magnitude direction continuously varies. In this load, both the magnitude and the direction is varies. So here refer the diagrams. Tensile load. Here tensile load. Here the beam is fixed beam, and the load, it is known as hook. In this tensile load, the load is acted on the downside. In this compression load, here the floor is fixed. Here dotted area as load known as fixed load, and the load is acted upon the hook. Here the load is acted upward direction. This is known as upward direction. This is known as compressive load, shear load. In this, both the bodies are at one hook, one link. It is known as shear load. Here the load is acted upward and downward. Here the two bodies are rubbing each other. This is known as shear load, and the torsional load, and the transverse bending load. This is also known as sum of the loads. First of all, according to the effect produced, what effort is produced when the two fixed beams are at the same position. Generally, it is classified into axial load, and it is sub classified into two types: tensile load and compressive load. And second one, shear load and bending load. And this is also referred as previous one loads. Okay, we know that shear force and classified into two types: shear stress and strain energy. Here shear stress, we know that load per unit area. Load, see that internal force is equal and opposite to the external load. The load resistance per unit area. In this one body have a body, when the load is applied, and it area is occupied by some of the stress. This is known as stress. Stress we classified as a load per area of a cross section. I sigma is equal to P by A. P is a load, and area we denoted as pi by 4 d square. Here SI units, load units was newtons, and area units were mm square or meter square. So it is classified as newton per mm square or newton per mm square. And the types of stresses, and in these types of stresses, it generally classified into three types: tensile stress, compressive stress, shear stress. In this, Tensile stress. Tensile stress, the load acting along the axis and perpendicular to the cross section of the normal. In this tensile stress, when the two acts in the opposite direction to the cross section. In this two body, one body moves upward and another body don't move downwards. In this tensile force is applied, and at certain point a failure is occurs. In this tensile force, sigma is equal to tensile load per unit of area of length. Sigma is equal to P by A. And second one is compressive stress. Compressive stress, axial load tending to compress or shorten the length, and the block end is called compressive stress. In this compressive stress, both the sides are induced. In this tensile stress, we know that both the forces are going outside, and this breakage is at the center of the body. In this, compressive force are coming inside the body, so that it will compresses the body, and it created and reduces the length. It known as compressive stress per unit area, total area. So third one is known as shear stress. Shear stress we know that known as the tangential load cutting or slides the part of the is called load, and the corresponding stress induced at the shear stress. The shear stress is equal to shear load per area of cross section. In this shear load, in this two opposite directions. In this one force is acting in downwards, one force is acting. In this two force between it will slides in, and it rubbing action is produced. So this is known as shear stress. Shear stress is known as shear load, where the shear load is acting per unit area of cross section. So shear stress is denoted by rho. Rho is equal to load per unit area cross section, P by A. So next video we will discuss about the full details of strain energy. So please cooperate engineering wala channel. Bye. We will discuss next topic in next class.